Okay, for the very last section here, this is applications of systems of equations. So word problems, read it, translate it into our equations to solve, and then solve. So we've got the sum of two numbers is 32. One number is 8 more than the other. What are the numbers? So first thing you want to do is define your variables. So x is going to be one number, and y will be my other number. So it says the sum of the two numbers is 32, so I know that x plus y has to be 32. And then one number is 8 more than the other, so I'm going to say y is 8 more than x, which is x plus 8, or 8 plus x. So I've got my 2 by 2 system here. I've got two equations, two variables, so now I can solve. And you can solve using whatever method you want. You can graph if you want to graph. You can use substitution or use elimination. Since this one already has y is equal to something, I would use substitution just because it's kind of set up for substitution. So I would take this and substitute it into this y. It's really your whatever preference you have for solving. So we would have x plus y, which is x plus 8. Is equal to 32. Solve, I have 2x is equal to, if I subtract 8 on both sides, I get 24, so x is 12. So then figure out what y is by plugging it into the first or second equation. We already know y is x plus 8, so y is 12, which is x plus 8, so y is 20. So the two numbers are 12 and 20. And you can verify 12 plus 20 is in fact 32, and 20 is 8 more than 12. So for the next one, I didn't write it down all on this paper because I have it up here, so I'll just show it to you on the screen here. A play was attended by 342 people, which are the adults and children combined. Admissions for adults was $1.50 and children was 75 cents. How many adults and children attended the play if total admission collected was $399.75? So I'm just going to write down the pieces we need. So there's 342 people. So that's a combination, if I can talk, of adults and children. $1.50 per adult. Oops, I can't write. For $1.50 per adult and 75 cents per child. And the total admission collected was $399.75. So that's the pieces that we need. So if you want to use X and Y, that's fine. I did on this. A lot of people switch over to A's and C's. A is the number of adults, so I'll do A and C on here. A is the number of adults, and C is the number of children. So if you've got two variables, you need at least two equations to be able to solve it. So you're going to have two equations. These are, you've got two things it tells you. It tells you how many total you have that attended. It also tells you something about how much it costs. So use the total first. So how many total attended? 342 people. So if we take the number of adults plus the number of children, it has to add up to 342. So my A plus C has to equal 342. So there's my first equation. My second equation I'm going to get from the cost, how much it costs. It costs $1.50 for each adult, 75 cents for each child, and we know they collected $399.75. So if I have one adult, it'll be $1.50, two adults will be $1.50 times 2, and so forth. So I'm going to have 1.5, if you want to keep the 0 there, times A, plus for children, if I have one child, it'll be 75 cents. If I have two children, it'll be 75 cents times 2, and so forth. So plus 0.75 times C. That has to give me the total amount of money that they collected, which is $399 75. So now I have two equations, two variables I can solve using graphing. You're probably not going to want to graph. It's got decimals and stuff, so you're probably not going to want to graph. So probably going to either be substitution or elimination. For these, because you have the decimals and everything, I would probably just do substitution. If you want to do elimination, that's fine. It doesn't make any difference. But what I would do is I would solve this for A or C. It doesn't matter which. I'm going to solve it for C. So C is equal to negative A plus 342, or 342 minus A, however you want to write it. And then I'm going to take this C and I'm going to plug it in to the second equation right there. So we're going to have 1.5 times A plus 0.75 times C, which is negative A plus 342. That has to equal 399.75. Then I solve my equation. I've got 1.5A, 0.75 times negative A is minus 0.75A. 0.75 times 342 is 256.5. Is equal to my 399.75. So 1.5 minus 0.75 is 0.75. If I subtract 256.5 on both sides, I get 143.25. And if I divide by 0.75, I get A is 191. So there was 191 adults, which means C is negative A plus 342, or like I said, 342 minus A, whatever. So C is negative A, 191, plus 342. So C is 151. So there was 191 adults and 151 children that attended. And again, you can check it. 191 plus 151 adds up to your 342. And then 191 times $1.50 plus 151 times your 75 cents adds up to the $399.75. So for our last problem, again, I didn't write that one down either. I'm just going to read it off the screen. A chemistry student needs 22 milliliters of a 38% acid solution. She has two acid solutions, A and B. Acid solution A is 40% acid and solution B is 30% acid. How much of each solution should be used? Usually this top problem is the most confusing problem. So I'm going to write down what we need. She needs 22 milliliters of a 38% acid. What she has is solution A, forgot my A, is 40%, and solution B is 30%. So how much of each solution should she use in order to make a 38% acid? So X is going to be my amount of solution A that I'm going to use, or that she's going to use, I suppose. And Y is going to be the amount of solution B. So, again, you've got two variables, so you're going to need at least two equations in order to solve. And so what you want to do is, first off, how much total does she need? She needs 22 mLs total. So however much of A I use plus however much of B I use has to add up to 22 milliliters. So that's our first equation. So X plus Y has to be 22. Now the second equation is a little bit trickier because now we need it to be the amount of acid. So solution A is 40% acid and solution B is 30% acid. So the acid in A would be, however much you use, would be 40% of that would be acid. So if I used 1 milliliter, I would have 40, 0.4 times 1 would be 40% acid. If I use 2 milliliters, I would have 0.4 times 2, would be the amount of acid and stuff. So it's a percentage. So the amount of acid in my solution A would be 40% to however much I use. So 0.4 times X. Plus solution B has 30% acid. So same thing, if I used I think it's in milliliters, 1 milliliter of solution B, I'd have 30% acid. If I use 2, I'd have 0.3 times 2 and so forth. So 0.3 times Y is how much acid is in solution B. So that's the acid in A, the acid in plus the acid in B. That has to be equal to the total acid, which we want to be 38%. And this is where people would stop. They just write down 0.38. But it's 0.38 of how much the total acid in the total is 38% of 22. So the 22 actually gets used twice because, like I said, it's not just 38%. You're not done. It's 38% acid in this 22 milliliters. So you have to make sure you multiply. This is the total acid in the total. So 0.38, which is 38% of the total amount that you're going to have, is 22. So don't forget that part. So generally that's where people, leave that off. So then you have this to solve. Well, you can multiply this out, 0.38 times 22 if you want to, and write that down. I'll do it in the next step here. So I think on this one, what I do, I used elimination for that one, just because I'd use substitution on all the other ones. I can do that again, I guess. So what I want to do is, we have usually on word problems I have a tendency to always use substitution, but 0.38 times 22 is 8.36. So if I want to eliminate, I need to pick a variable to eliminate. Both x and y have a coefficient of 1, so either I can eliminate x or I can eliminate y. This one has 0.4 in front of it, this one has 0.3 in front of it. I saw on the notes that I posted, I eliminated y, because 0.3 is smaller than 0.4, but it doesn't really matter. So what I'm going to do is take, if this one's a 1, I need it to be a 0.3. So I'm going to multiply this whole thing by 0.3. And again, we want to be able to add. They're the same sign, so I need to make one of them a negative. So I'm going to make this a negative to switch the sign. So I would have negative 0.3x minus 0.3y is equal to 22 times negative 0.3 is negative 6.6. We didn't do anything to the second equation. So now I'm going to add these together. So I've got negative 0.3x plus 0.4 is 0.1x. Negative 0.3y plus 0.3y goes away. Negative 6.6 plus 8.36 is 1.76. Divide by 0.1 and I get 17.6. Then to find y, I'm going to plug in my x, 17.6, either into my first equation or my second equation. I'd probably use my first just because it doesn't have the 0.4 and 0.3 in front of it. It's easier to use. So I'm going to have x, which is 17.6, plus y has to be 22. So subtract, so this is from the first equation, subtract 17.6 on both sides and I get 4.4. So she would need 17.6 milliliters of solution A and 4.4 milliliters of solution B, and that would make her 22 milliliters of a 38% acid.